We are up to lessons 4 and 5 of Unit 3. And what these lessons are about is an offshoot of what we learned about in the previous lesson. In the previous lesson, we learned about how square roots are the same as raising the power to 1/2. Cube root is the same as raising to the power of 1/3. It turns out that pattern holds true for all roots, so the fourth root would be the same as raising to the power of 1/4. The fifth root would be the same as raising to the power of 1/5, so on and so forth. That covers all fractional exponents where my numerator is 1. 1/2, 1/3, 1/4, 1/5, etc., etc. Well, what happens if I have a fractional exponent, where the numerator is something other than 1? That's what this fractional exponent rule is for. So that's this part right here. Okay? So it turns out that when I have a fractional exponent, the denominator is still the root. The denominator is still the root. So if the denominator is 2, it's still a square root. If the denominator is 3, it's a cube root, so on and so forth. So that still holds true. What the numerator tells us the exponent. So that exponent could go on the inside or outside the root. So I have an example of that here, of how that formula works. So again, the denominator tells me the type of root. The numerator tells me the exponent, and that exponent can go inside or outside the root. With that in mind, let's take a look at our examples here. So we have 5 to the power of 2/3, and we want to write that using roots. So just like I said a minute or so ago, all right, we're going to write it using roots. So we're going to write it like that. The question is, first of all, what type of root is it going to be? Well, again, the denominator tells me the root. So the denominator is 3. So that tells me it's going to be a cube root. So that tells me it's going to be a cube root. All right, the numerator is a 2. The 2 tells me the exponent. So the exponent can either go inside the root or it could go outside the root. So when I say outside the root, that would mean it would look something like this. Either one of these would be considered correct. Okay, the key is the exponent could go inside or outside the root. So number two, again, we're raising 5 to the power of 4/3. Okay, the denominator once again is 3, which tells me the root is going to be a cube root. And this time, the numerator is 4, so the only thing that's going to change between number 1 and number 2 is that the exponent is going to be to the power of 4 instead of to the power of 2 as it was in number 1. So again, that power of 4 can go inside or outside the cube root. So that's going to look like this or like this. Either one of these, again, would be considered correct. Number 3, 5 to the power of 3/2. So what is that going to look like? So the denominator of 2 tells me that this is going to be a square root. Now, you guys already know this, but when I have a square root, I don't actually need to write the 2 in there. If I have a root where there's no root written here, I assume it's a square root. So this is going to be a square root, and then the exponent is going to be 3. So that's going to look like this or like this. So the square root of 5 cubed or the square root of 5 cubed. Number 4, now we have 5 to the power of 3/4. So again, we'll set it up like this. The denominator of 4 tells me it's going to be a fourth root. So a fourth root of 5, and then the exponent is going to be cubed again. So it's going to be the fourth root of 5 cubed, or the fourth root of 5 cubed. All right, so just to recap, again, the denominator of the fractional exponent tells me the type of root. So 2 means square root, 3 means cube root, 4 means fourth root, so on and so forth. The numerator of the fractional exponent tells me the exponent, and that exponent could go inside, as I did over here, or outside the root, as it did over here. So that's 1 through 4. 5 and 6, we're basically going to do the opposite. We're going to go in the opposite direction. So we're going to go, instead of going from exponential to roots form, now we're going to go from roots to exponential form. So we're going to write this as a fractional exponent. So 5 to the power of something. So in number 5, I have a fourth root. So that tells me that the denominator of the fraction is going to be 4, which means the numerator is going to be 7. So number 5 is going to be 5 to the power of 7/4. 5 to the power of 7/4. On number 6, notice there's no root indicated here, so this tells me it's a square root. The root is the denominator. The denominator tells me the root, so it works the same way in the opposite direction. So this tells me that the denominator is going to be a 2, and thus the numerator is going to be a 9. So number 6, the answer is going to be 5 to the power of 9/2. So 5 to the power of 7/4 and 5 to the power of 9/2. That is it for this lesson.